I'd like to introduce our last long talk speaker. We still have a very exciting lineup of speakers today, but Thodoris is really one of the people we thank you for taking the last slot, but really last but not least, because he's going to talk about some really exciting new work on bridging predictions and interventions in recommendation in the social media setting. And Thodoris is assistant professor in ORC at MIT. Yes, confirming if this is correct. Yeah, we're a little bit unrehearsed on the last day. I'm so sorry. Thank you so much, and looking forward to your talk.
Thanks, Lydia, for the introduction, and thanks to Deb, to Lydia, and to Angela for the invitation. It has been a wonderful week. I'm very happy that I'm here. So today I will talk mostly about how can we schedule posts in social media for content review. So this talk will be about content moderation in social media in general. So I do not need to convince you that social media have changed our everyday life, from the way that we're interacting with each other, advertising our businesses, making purchases, you name it. Now, an interesting aspect of social media is that they exhibit a network effect. So users are interconnected with each other, and as a result, any information that's created by one user can very easily propagate to other users. Now, most of the content that's created in social media tends to be benign, but there's also often some content that, for example, may incite to violence or may involve bullying and harassment or other forms that are harmful for the users. And so the social media platforms create particular policies that specify what exactly constitutes as harmful content. For example, Meta has the community standards that specify the categories of what is harmful content. Now, one challenge that arises in social media is that once such a content is created, because of the network effect, it can very easily propagate throughout the network, and therefore the negative impact of those posts can be greatly exacerbated and amplified. So as a result, as we said, social media platforms like Meta, YouTube, TikTok, all of the major social media platforms spend significant resources in order to try to avoid, to remove abuse from the platform. And this is not only a promise that the social media platforms have to the customers, it's often also a legal requirement. In particular countries, there are laws that specify that if you have more than a particular number of users, in the order of tens of millions typically, then you're required to actually spend resources in order to make sure that you do not have abuse in your platform. Just to give you a sense of scale, platforms like Meta and TikTok tend to have something like 40,000 human reviewers that they are employing in order to help remove malevolent content. And this is data from 2024 when we started this work. They were spending like $5 billion on the content moderation systems in this year. Just to give you a sense of scale, this could correspond to something like 4% of the annual revenue of Meta and 13% of the annual profit. So this is a big amount of investment. Another way to try to think about the impact of improving those systems is by understanding how prevalent is the negative content, the harmful content in these platforms. And as you can see, for every particular category, so for example, for violent and graphic content, this is only something like 1 every 1,000 posts. So maybe you will think that, okay, this is not a severe problem. But if you think about how many posts we're having, this actually translates to hundreds of billions of users who are engaging with violating content every year. So even modest improvements on how we can design other systems can actually have material impact on reducing the prevalence of harmful content to the users. Yes?
But the content versus the users versus the views, is it the case that basically those views are kind of evenly spread amongst users, or is it the case that there are just some users that are really engaging more with that content, whether they want to or not, but like that it's really concentrated among certain users as opposed to?
Yeah, the views are not equally distributed. This is an estimated number based on the average views, the average time that the user is spending, and the average views that you're getting through the time and how many users you're having. So this will be all of those are averages, and the spreads are going to be different for different users. Okay. Other questions? Yeah. Feel free to stop me at any point. I'm very happy to make it.
Billy with a B?
Yeah, with a B.
Okay.
Yeah. Okay. Good. Okay. So at its core, content moderation is a classification task, right? There is a post that is arriving. There are some pre-specified categories of what constitutes negative content or harmful content. And the goal is to try to keep the content that is not in one of these categories and remove the content that is in one of these categories. So the good content that does not violate the community standards should be kept. The bad content that violates the community standards should be removed. For example, this is a workshop that I organized 3 years ago at Simon's. This, to the best of my knowledge, does not violate the community standards of Facebook, so should be kept on the platform. It's a good post. It was a nice workshop as well. But on the other hand, if you have a post, again, as we said, that involves harassment or bullying or violence, incitement to violence, this post should be removed. So this is one example. Now, because this is a classification problem, one approach that we would be thinking is that we should be using AI in order to actually solve that. And indeed, most big platforms like OpenAI and Anthropic and Google AI have automated content moderation systems in order to help enhance make those classification decisions. So one question that you may be wondering is, okay, like why don't we just rely completely on AI? The reason why this does not happen in practice, and companies actually spend significant resources on that, is because although AI can be very responsive, it can also be prone to errors. And this is because content moderation can be an inherently challenging prediction problem, and also there is much non-stationarity in the trends, in the type of posts that are coming, and also non-stationarity in the policies. For example, in the last 5 years, what exactly constitutes harmful content has been evolved over time in many social media platforms. And what makes things even more challenging is that it is not only that we need to try to keep abuse away of the platform, we also need to care about this other type of errors. So we care both about the type 1 errors and the type 2 errors. For example, if you were to actually remove 1% of good content, this could mean that millions of people would have their free speech rights infringed, for example, right? So in order to deal with that, what most social media platforms do is that they're having human reviewers assist and complement these AI automated systems. So, for example, Meta and TikTok are employing 40,000 safety professionals or human reviewers in order to enhance their processes. As you can see from the numbers, although we actually have a significant number of reviewers, we cannot hope that we will be able to actually review all the posts because you're getting something like a couple of billions of posts every day. So with 40,000 reviewers, obviously, you will not be able to review everything. So what those companies tend to do is that they employ an AI human pipeline where they try to combine the responsiveness of AI and the fact that AI is relatively accurate with reliability of humans. So a key question in all this work is which posts should we defer to humans and how do we make the decision about when will we trust AI predictions or when should we intervene in order to actually send to humans and improve those decisions. So let me describe the AI human pipeline in content moderation. So if you're Meta, you're receiving something of the order of a couple of billions of posts every day. When a post is created, it automatically goes through some large AI models. And those AI models need to determine whether the post should be kept on the platform or should be removed on the platform. This decision needs to happen immediately because if you decide to wait, you are temporarily removing the post, for example. right? So you are making an initial decision of whether the post should be kept or removed from the platform. Then you're also making an admission decision where you decide whether the post should join a queue from which it will be eventually scheduled to human reviewers, and then human reviewers can intervene in the process subsequently and potentially correct the mistakes that the AI classification decisions, the prediction decisions from AI have made. But they also have a second role. They also have a labeling role because they can provide label data that can help enhance future classification decisions. So the humans have a dual role. There's an enforcement role, correcting classification decisions for the current post, but they also have a future a labeling role because they can provide label data that can enhance classification decisions in the future. So in the first paper that we wrote with my PhD student, Wen-Tao Wang, we formalized this process, and we provide the algorithms on how you should make this admission decision in a way that takes into account both of these roles, both the enforcement role and the labeling role. And in the work that I will describe today, I will focus mostly on the scheduling question, which says once the posts are admitted to the queue, how do we make the decision of what posts are we going to prioritize for human review? Any questions on the high-level pipeline of, yeah?
Do you have the sense that the human reviewers are, in fact, like more reliable than the AI system? Like this is sort of well established.
So there is it is well established that they are more reliable than AI. Now I'm going to assume in the talk that I'm giving that they're actually going to be perfect. There is evidence that they're not perfect, and in fact there are different categories typically that different human reviewers will be differently accurate for different posts. An example for that would be language. Like there is reviewers who speak a particular language. They're going to be more adept to review a post that's coming from a particular language. So there are differences in exactly the skills that they're having. In general, they're more reliable. That's the reason why they're used. For this talk, I will assume that I will take the extreme approach that I will assume that they're going to also not make errors. So to make it as extreme as possible. Yes.
Where does if someone reports a post, how does that feed into this?
Great. So the reporting the post, I'm not capturing it directly. Typically, in the model that I will describe, it will be captured because we will think the number of appeals as part of the state of the post. So I will capture that in the model that I will discuss later. Generally, when somebody appeals, this goes through a different system that goes to expert reviewers that are going to subsequently be allocated for the particular appeals that are happening. But yeah. Yes.
I think sometimes in these pipelines, you have ambiguity or vagueness in the application of the guidelines to certain cases, and I was kind of curious, how you address that in this workflow. Is there a step where you're kind of allowing for revision to the policy, or are you kind of assuming that the policy in the set of categories is sort of fixed?
Yeah. So in this particular pipeline, I'm not going to address the ambiguity. In practice, you tend to have posts reviewed by multiple different humans, and if they disagree with each other, maybe it's going to go to an additional tiebreaker somehow. So you try to deal with ambiguity, and this connects back to the point that we were discussing before about errors. Like ambiguity, also you can think of it as errors with respect to that. One important component that I'm going to point here is that there are concrete guidelines of what should be allowed or not. So there is a notion of ground truth. But it may be the case that the reviewer is not able to actually completely follow the guidelines. But there is a sense of an expert reviewer, two expert reviewers are not going to disagree because there are well-specified guidelines in the process. And I'm not talking about misinformation here, right? I'm talking more about content that actually, falls in a particular category. Yeah. Any other questions? Okay. Any questions? Again, more than welcome whenever you want. Okay, so what is the simplified setting? So as I said, I want to focus on the scheduling decision. So in order to delve into it in more detail, I will simplify the other parts of the process. So one assumption that I will make is that the admission of posts is exogenous. So there's a stream of posts that's arriving in the queue. As I said in the previous paper with Dial about how do you actually make the admission decisions. And now what happens is, so there's a stream of posts that's admitted. We will also assume that all the posts that are admitted are kept on the platform. This is actually in accordance with content moderation practice. Now, because we assume that the posts that are admitted are kept on the platform, when a reviewer reviews a post, they can decide that it was a good decision that the post was kept on the platform, or that the post actually violates the community standards, in which case the post is subsequently removed. And on the point that we were discussing before, I will make the assumption that there are no errors of the reviewers, so whenever they're making a removal decision, you're not going to have false positives or negatives, I guess, the other side of error. Okay? So that's the simplified setting that I'm going to assume. So let's discuss what's the goal. The goal, informally, is that you're going to minimize the negative impact of violating posts, right? Because we are in a situation now that we're only considering posts that are kept on the platform. You do not have the other type of errors, so you don't need to consider the cost of accidentally removing a good post. So in this simplified setting, our only goal is to try to minimize the negative impact that's coming from violating posts. Now, as we said before, once the post is creating, initially, it is only viewed by the content creator, right? Only the content creator is able to view the post. But because of the network effect, as time goes by, it will propagate throughout the network, and therefore its negative impact can be potentially amplified. So intuitively, we can think of the negative impact of a post as being proportional to the number of views that it will be receiving. The more people view the post, the higher the negative impact is going to be. So the way that most social media platforms formalize this goal is with a notion of prevalence. And the prevalence would say that for every particular post, it contributes as a cost only if it is violating, so it is an indicator of whether the post is violating, times the number of views that it will receive before it is reviewed. And all of them are adjusted by the severity of the post. Not all different posts have the same severity. So the reason why I'm focusing on what happens before review is that once a post is reviewed, it's either the case that it's a good post, in which case it will not anyway consider any harm, or it is a bad post, in which case it will be removed, and as we said, the reviewers do not make errors for simplicity here, so in this case you will not have any additional cost that is coming subsequently. Okay? Any questions on the objective? Okay, so that's the objective that we care about. Both Meta and YouTube actually specify that in their community standards that this is the way that the objective is formalized. Now, does anybody see any challenge in actually trying to measure this objective in practice? So you are at any particular point and you want to try to understand how bad the prevalence of violating posts is in this particular category. Angela? Is censored between the times that yeah, so you only have information about the posts that you are reviewing, and the number of views, of course, that you're getting will be truncated based on the posts that you have reviewed, right? Correct? Mm-hmm. Any other thoughts?
Sorry.
Yes.
So the harm from falsely taking down a valid post is not something you're including?
I'm not considering it in a simplified model because I said that I'm only interested in situations where the posts are already kept. So in the simplified model. In the first paper, we're actually thinking about the trade-off between taking down a good post and removing a bad post. But for this focus, this simplified setting, I'm only considering the cost that's coming from keeping a bad post, essentially. Yeah.
And there's no notion that, like, because this isn't in like the meta standards, but like that a post could become harmful only after it reaches a certain size, right? There could be a post that is fine if 3 people are sharing it, but if it were to spread broadly, it'd be bad.
I'm assuming that the cost is linear, separable across the users, essentially. Yeah, that's a good point. Yeah, good. So, as we said, as Angela said, we do not actually know the number of views of that you will see before review is going to be changing based on the decision that you're making. But actually, this part of the number of views that you're receiving before review is something that you can know at any point. What you do not know is whether the indicator of whether the post is violating, because the only way that you can get labeled data about whether the post is violating is by sending it to human reviewers. For most posts at any point, you do not actually know whether a human reviewer has what is the label of this post. So what is typically used as a proxy of this objective is replacing this indicator of whether the post is violating with a probability that the post is violating. So this is predicted initially based on the initial AI system will predict what is this probability of being violating. And companies actually have online learning models to learn that online. So this is a paper with 20 authors from mostly from Meta. Hamza is also there. That provide an online learning heuristics that has been deployed at Meta in order to learn those probabilities online. And the previous paper that I discussed with Wen Tao is actually providing a formal treatment of this problem and also showcases inefficiencies of typical heuristics and how you can fix them in practice. Yes, sorry.
One thing, so it's the same model that's doing the initial decision is where the probabilities are coming from?
Typically, you have different models that estimate the probability. There is a probability. So the typical way that you are acting is that you have several different models, big models, that each of them targets a different category of violation. And then you have somehow some aggregator model subsequently that combines all these predictions and confidence intervals that you're having. And based on this, you're finally making the eventual decision. But yeah, I'm putting all of them in the same box of AI. In this.
So like, that means that in this case, those probabilities are all going to be small because they
sure.
pass through, right? Because they've been accepted. If the probability that the post is violating under the aggregate model was high, yeah. That means that one of the models would have kicked in
right.
initially, right?
So what really happens, and that hints on what you do on the admission, really you have three regions. You have an accept region, you have a reject region, and you have a defer region. So there is the posts that are going to be accepted that are very, very low probability of violation are anyway going to be removed automatically, are going to be kept automatically. The posts that are rejected are going to be removed automatically. And really what the posts that are going to the queue are the ones that are, you're kind of have a certainty, and those are the posts that you're putting in the queue essentially. Yeah. Yes. Mm-hmm.
How is the violation measured? So, does humans, report the post, or you have classification of okay, this image has this materials, this text is toxic.
So this happens automatically. These probabilities of violation happen automatically when a post comes. Yeah. So for every post that's coming, you are getting.
So you have some classification model to
They have different classification, different large language models that try to find the different probabilities of different violation types. And then you have some way that you aggregate this information in order to make a final decision. And you make, as you said, it's accept, defer, reject. So you need to make these three decisions essentially.
Is it humans, reports also counted in this?
Yeah, so that relates to the previous question. So I'm not capturing directly in the system, and that's an interesting open direction of capturing it. But in practice, what you have when somebody reports, it will join a dedicated queue that is going to go to expert reviewers that will deal with it in a separate system from that, like you are going to go tomorrow. Yeah, we are capturing, as you will see, we are capturing appeals potentially in the scheduling component, but I will discuss that when I talk about the formal model. Okay, so in this paper, I will not consider how do we learn those probabilities. Again, there are online learning heuristics in order to learn them. I will just assume that we know those probabilities in advance. So when a post comes, we're going to assume that we run these big, large language models, and they produce eventually the probabilities that we care about. And I will also assume that these are known and they are correct. Okay, that's kind of I mean, there are questions about how to learn them and dealing with errors that are going to be orthogonal to what I'm talking about. Now, we are referring to this proxy as prevalence-based holding cost. The way that you should be thinking of it is that at any period, by not sending it to human reviewers, you are incurring a holding cost from holding the post in the queue, which is equal to the number of views that the post is going to get during this period times the probability that the post is violating. Now, to simplify presentation, and this is only for the talk, not for the paper, I will also assume that all these probabilities are actually the same, because all the challenges that I will discuss are actually arising even in the case where all these probabilities are the same. Okay? This is not for the paper again, but for simplicity, let's assume that every post that is arriving has exactly the same probability. So the holding cost that we're having is we can write it now as a sum of the views that the post is going to receive before it gets reviewed. And the question is, how do we schedule posts in order to minimize this holding cost? And the challenge that we're having is that the view trajectory of the post, as we discussed with John before, we're assuming that there is linearly separable with respect to the views, so you need to care about the views. But the view trajectory can be very, very uncertain. This is a paper from VLDB paper from Meta, for example, that exhibits uncertain pattern. And actually work by John and others has shown that as you're observing more information, you can actually get better prediction of the future. So there is a promise also that as you're getting more information, you are able to actually enhance your decisions. So in order to highlight the key ideas, both algorithmic ideas and get you better familiarized with the problem, I have a warm-up quiz here. So in a minute or so, I will ask you to vote, so please pay attention in order to vote. It's last day, so we need to keep it a little interactive, right? So our setting is going to be a sequential setting. So in every period, we're going to have two posts that are arriving. One is going to be a text, and another one is going to be a video. So we have a small content moderation system, those are the two posts that are arriving. Now the text is going to have a cost of 2 for the first 5 periods after its arrival. So in period 1, after its arrival, it's going to have 2 until period 5, subsequently it's going to have 0. The video can either be a blue video or a red video. If it's a blue video, it will have cost of 3 in the first period after its arrival and 0 afterwards. If it's a red video, it's going to have cost 3 after its arrival, 6 from periods 2 to 5, and 0 afterwards. Okay? This is all the notation I have. Yes?
How is this modeling the potential virality cost?
Good. The cost corresponds to the instantaneous number of views. Not, so the virality is captured by the trajectory. So a viral post is going to, the red video is a viral post because it will become 6 in the future. But yeah.
Should I interpret the cost as like the harms from virality? So both that it is going to be viral plus it has some causes some user harm.
It is the instantaneous cost is for every period, the probability that the post is bad times how many people view it.
Okay.
So that's kind of capturing a combination of both of them. Yeah. Okay. So does this make sense? And we know this view trajectory. We know this trajectory, this structure. But the key thing is that at any time you can only observe the holding cost for the current period and not for the future. So in the first period after a post arrives, you can know that the holding cost of a text is 2. So you know that it's a text also. But you only know that the holding cost is 3 for a blue video and a red video. You do not know whether it's a blue or red. You will only be able to disambiguate the two after one additional period when you will be able to see that the blue video has 0 or the red video has 6. Okay? Does it make sense? That's all the notation I have for my quiz. Make sense? Yes. Yes.
If you're worried about harms from unreviewed videos, why don't you just not allow the post to appear on the platform until the whole review period? Is
Excellent.
there some,
So that's what I said in the first paper that we wrote. There is a question of which post do you remove initially. Potentially you can remove a post temporarily and subsequently bring it back once it is reviewed. There are situations where this can actually cause non-linear harm. For example, if you want to advertise an opportunity that is for the next 10 minutes, then keeping it for 10 minutes, then the post becomes irrelevant. So I'm simplifying the setting by only considering the posts that are kept and not considering this type of post. In practice, that's a consideration. The previous paper that we wrote was trying to tackle this amount of this consideration that you're saying. Yeah.
Thanks.
Okay, good. Okay, our quiz. Okay, we have the two posts that are arriving, a text and a video. For the text, we know exactly the holding cost trajectory. For the video, we will only know that after the second period. We're only able to review a single post. So when you review a post, it is removed from the queue and is not going to give you any additional cost. So the cost that we're incurring is the cost of all the posts that are in the queue and are not reviewed. So, and you can make the same example if you were to count the cost before the review, but I'm not going to go on there. So what's my quiz? You are in the first period. You are going to receive a text and you're going to receive a video. Okay? You can only review one of the two. Which one would you want to review? Who would like to review the text? Don't be shy. Who would like to review the video? Okay, we have majority videos. So you're in good company because that's what canonical scheduling theory and practice actually tells us. So the intuition about why you may want to review the video is that it has higher instantaneous holding cost, right? It has, the text is going to have a cost of 2, the video is going to have a cost of 3. So by removing the video, you're saving more today. This is actually known to be optimal when the holding costs are convex, and this comes under the name of CMU rule, and one of the heuristics that Meta has disclosed to use, the velocity heuristic, is actually applying this in practice. Another reason why you may want to review the video is because it has the highest expected holding cost. So if you think about the expected cost of a video, or the text is going to be 2 times 5, so 10. Well, for the video, you're going to get 3 in the first period, and then expectation 3 for the next 4 periods as well. So again, the expected cost from a video is higher than the expected cost from a text. And again, this is known to be optimal when you have linear holding costs and an abandonment probability of theta. And another heuristic that Meta has disclosed to use, the PIV heuristic, is applying this in practice. So canonical theory and practice both suggest that you should review the video. Presumably, you have already inferred that the reason why I have this quiz is that this is not the correct answer. And why is this not the correct answer? What happens when you review the video is that initially you're going to get a text and a video, and you're going to review the video. Then there will be a new text and a new video that's coming. Again, you're reviewing the video. So any incoming video is going to contribute a cost of 0 because you're always reviewing it, removing it directly. Now, this also means that all of the texts are actually piling up in the queue, and therefore you're getting a holding cost of 10 from the text because 2 times 5. Alternatively, a better thing that you could do is that you could wait, you could review the text initially, and then wait to see whether the video turned out to be red or blue. If the video was red, you can review it and save the cost of 6 in the future. But if the video was blue, which you will know in the second period after the post arrival, then at this point you do not need to review it and you can save capacity to review incoming texts. So what this means is that the video is going to contribute a holding cost of 3 initially because it always stays on the platform initially. But the text, an incoming text is only going to contribute holding cost of 10 with probability half only if the video of the previous period was red. Because if the video of the previous period was blue, then you actually are able to serve the incoming text, which means that you get an expected cost from the text that is equal to 5, which means that the total cost of your system is smaller. So what does this highlight? And that's the main idea that I want to convey. What canonical theory and practice here is missing is that they ignore the fact that there is the uncertainty in the view trajectory in this particular case can resolve over time as we're observing better information and as we can improve the predictions we have for the future. And we will have the opportunity to review a post in the future once this uncertainty has been resolved. Any questions on the quiz? Okay, so the main question that I'm asking is how can we dynamically schedule post reviews in a way that captures these uncertainty resolutions in the holding cost? And let me describe the model and the algorithm. So the model is that at any point you have some posts in the queue that are unreviewed that I denote by q of t minus 1. Then there will be a stream of new posts that's arriving. As we said, this is exogenous, and I will assume that it follows a binomial distribution. And then you will review a number of posts that you are able to review a number of posts. Once you review a post, this post is removed from the from the queue, and you will make this decision after you observe the state of the system. And this is where we are going to actually capture appeals and other information. So what is the state of the system that will capture this uncertainty resolution? Let's go back to the workshop that I organized here. So the features that we're having, there are some static features that are information that's created at the content creation time. So for example, this information is the content, who is the creator, the time that the post is created, etc. And you also have some temporal features such as appeals, such as views, such as shares, such as likes, that can evolve over time. For example, if I go there and I like this post, then actually the number of likes is going to increase. So this kind of changes over time. Now in practice, Meta has disclosed to be using 1,000 different features, engagement features, page features, bunch of different categories. In that, some of them are static in the sense of they're fixed at the creation time, and some of them are temporal because they're changing over time. The way that we're modeling it is that we're assuming that there is a Markovian tree structure, and if you are at a state that is at depth L, this captures all the information that's available in the first L periods. So the static features will be L equals 1 because it's only the information that is available at creation time. Temporal features will be higher L because over time this is going to become richer and richer. Two pieces of notation just to state the results. I denote by P of S the transition probability from state S to child states, and C of S the holding cost of state S. And so the holding cost of a job J at period of a post J at period T is going to be C of S J of T. And we're going to assume also that there is a terminal state, that after some point you're going to reach a state in which you're going to have 0 views subsequently. Any questions on the model? Yes, Angela?
So you point out that you get more information as time goes on. Yeah. I was wondering the probability of violation given the post. Can you also condition that on the trajectory of views?
That's a great point. That's a great point.
Model general enough to handle that?
In general, you should do that. It's much trickier to actually estimate these probabilities. Sure. So the state space actually is huge here because it captures all of the possible information. And one nice thing about the results is that they're not going to scale with the state space in particular, right? So if you were to actually in practice, you have more information about the probability that the post is violating, that maybe posts that are more viral are more likely to be violating, for example. This is typically handled by different teams, so this is not typically what is happening. Typically the probabilities are predicted initially, and there is a challenge about how to estimate these probabilities in such a large state space, but this is an interesting direction to think about because in practice you would be able to actually use this information in principle as well. Yeah, John.
I'm curious of some connections. So there's this old work of Moore, Harkle, Walter on queuing theory and process scheduling, where she says because lifetimes of jobs are heavy-tailed, you should sort of run for a little while to figure out the parameters and then decide sort of how to schedule it after you've seen whether it's going to. And that also sort of has the property of scheduling where you let the item age slightly in order to decide. Is there some connection technically they both seem to have this property that I should wait a little bit so that it resolves the uncertainty rather than
we do not necessarily wait for the same amount of time for different posts because each post has different features. So maybe a post that you know that deterministically is going to be viral, you want to actually review it directly. So it's not necessarily, if you had a homogeneous population of posts, I would assume that something like what you're describing is probably going, or if you had a single dimensional, for example, information, maybe something of what you're describing is going to be, to potentially be optimal, like thinking about, but yeah, the analysis we have comes from queuing theory and analyzing presumably similar techniques here. Yeah. Thanks, John. So what's the objective? The objective is that the cost of the algorithm is going to be a time average, where the cost of every period is going to be the sum of the instantaneous holding costs of all the posts that were in the queue at the end of the period, and we're going to compare it to the cost of the best possible algorithm. So let me say the results. On the theoretical side, we're showing that if you have the terminal, you will go to terminal state after L periods. So if the terminal state if the tree has depth L, and you also have some non-zero abandonment probability, which means that there is a probability to go to the terminal state after a non-zero probability to go to terminal state from every state, then we provide an algorithm that's asymptotically optimal in the sense that it stays sublinearly with the system size, and it has no dependence on the size of the state space, which can be huge, and we only have a logarithmic dependence on the depth of the tree. On the practical side, we are testing our algorithm for a simulated environment from real data at YouTube, and we're showing that you can get a reduction in the prevalence that is of the order of 3 to 8% if you were to fix the same review capacity, the same number of reviewers. So by fixing the same number of reviewers compared to the two heuristics that I described to be deployed, you get a 3 to 8% reduction. If you're going to translate that in practice, as I said, this could correspond to billions of violating views that are smaller, because we have hundreds of billions of violating views every year. An alternative way to think of it is you're going to keep the same prevalence level, and you're going to think how many less reviewer hours can I have. And there we can get that we get 7 to 25% reduction in reviewer hours. Again, if you want to translate that in practice, if this is realized in practice based on the data from Meta, this corresponds to hundreds of millions of dollars every year. And we have been running an A/B test at Meta to test this algorithm in practice. We have seen promising results. I'm not at liberty to actually say more things, especially on camera. Yeah. Yeah. Okay. So if realized in practice, this approach can actually have reduced billions of views of violating content, and also potentially save hundreds of millions of dollars, depending on what you want, how you want to view that. So, do I have time, or have 5 minutes, or? Okay.
Are you almost done, or?
I want to give a hint of the algorithm, but I'm happy to. It's
maybe 5 minutes.
Yeah, 5 minutes would be fine. Yeah. Okay, great. So what's the hint of the algorithm? So the algorithm. Remember that we're going to review RT posts, which is this. We have a number of posts that we can review. An easier setting that we are going to ask you to consider in order to design the algorithm and then connect it back is that we can always pay a price gamma star to review a post. Okay? So this makes all the posts independent from each other. And this will be the dual of a relaxation of a mathematical program that will connect it back to the review ratio. So this becomes, so then the posts are actually becoming independent ski rental problems. Because what is ski rental? In ski rental, you have a skier that is going to ski for an unknown number of days, and they face this dilemma: should I buy the ski equipment initially and then I pay high upfront cost, but then I have the ski equipment throughout, or do I rent it for a lower cost, but then if I want to ski again next week, I will need to pay the cost again? So how do I make this decision at the face of uncertainty? Now, in our case, the buy option is the equivalent of the reviewing the post. If you review the post, you pay this price, gamma star, but then you will have zero cost subsequently, because you reviewed the post and therefore you removed it if it was violating, or you kept it if it was not. The rent option is the equivalent to not reviewing the post. In this case, you pay the instantaneous holding cost. As we said before, this is the probability that the post is violating times the number of views today, but the post is going to stay in the queue, so potentially is going to contribute cost in the future as well. So our algorithm really defines this value function that is the minimum between the buy and the rent option. The buy option is to pay the gamma star, the price. The rent option is having the instantaneous holding cost plus the expected holding cost that is coming by transitioning to a child state according to the probability distribution. And we're calling this algorithm, because this value function is adjusted by the opportunity of serving a cost in the future, we are calling the opportunity adjusted remaining cost, or OARC. We were debating to call it ORC, but when I was in ECS, so we decided to not go with that. So our algorithm, which we call ORC, essentially solves this capacity price, the gamma star, as the dual of fluid relaxation, and then just ranks all the posts based on these rent indices and decides based on that. And this is for the theoretical analysis, and for the theoretical analysis, we show that this algorithm has optimality that is asymptotically optimal. In practice, we are actually also creating a data-driven approximation of this algorithm to address several challenges that arise in order to actually make it in practice and being able to run it. I'm happy to discuss it offline. Okay, so let me recap. What I talked about today is try to describe this pipeline, this AI-human pipeline that arises in content moderation, and we focus mostly on this scheduling component. And the challenge that we are having is that there's a lot of uncertainty in the number of the view trajectory and the number of views that you're having in the post-virality. And on the theoretical side, we provide the model that is about the resolution of this uncertainty, takes into account the resolution of this uncertainty, and is also asymptotically optimal. On the practical side, we can get significant improvements both with respect to prevalence, of reducing the prevalence of violating content, and with respect to reviewer hour savings. And I guess if I want to just give a broader picture even beyond content moderation, one way to think of it is that this pipeline that I described for content moderation, I think is a general pipeline that arises in general in over-congested systems, in systems where we will need to use AI, but you have very limited amount of human resources. And so I think it's a good model to think about human in the loop when you need to have AI automation. In general, there is AI automation and AI augmentation. AI automation is the situations in which you need to replace some of the humans with AI. AI augmentation would be when AI is assisting the human. So this would be a model for the AI automation component about deciding how to defer to humans. And the key challenge is that AI predictions need to trade off between false negatives and false positives. This is the general challenge that we discussed before about keeping a bad post or removing a good post. Deferring to humans needs to balance between correcting the current decisions and improving the future predictions. This is the component about the dual role of the two humans. And I think that general, again, that's more broad beyond content moderation as well. And generally, I think that generally when you think about interventions, you may think about, you may want to account for the uncertainty resolution, the opportunity to intervene in the system in the future, not just today. So thanks, and I'm happy to take any additional questions. Thanks.
I have a question. Is it possible for the human reviewers to have any agency in terms of the queue? So can they reject certain items that you propose to them to review, or do they have to review everything that's shown to them?
No, they are getting a list of posts, and they need to make a decision on each of them.
Okay, they have to make a decision for every single one.
Yeah.
Okay.
So let's take the rest of the questions during break, and then we'll come back at 11 for the next panel discussion and provocation. Thanks, everyone.
Thank you.